Well, hello friends. Welcome back to browser hacking. Today we are going to continue a little bit on the google.com homepage because yesterday we just got it loading, right? And today I figured we could take some new issues off the table here. So you immediately notice that they have a new Google Doodle thing, which is an interlaced GIF, I think. So it looks off. But I wasn't actually looking to work on the GIF decoder today. I wanted to do some HTML stuff. So we're going to take these hidden input elements here. They're supposed to be hidden and actually make them go away because this looks really awkward. So I think what we'll do is we'll just go in the input element. And so the way that these work right now is that every time when we build the layout tree for web content, then what we do is we just iterate the DOM and we work out based on CSS like what kind of display box or like what kind of layout representation should each DOM node have. And we call this virtual function called create layout node on the DOM node, passing it the CSS style that we found applies to this element through selector matching. And so then it's up to the element to produce potentially like a tailor-made layout node. Otherwise, like if the element does not override create layout node, then we will fall back to the default element create layout node, which only looks at the display property here. So you can see none, block, inline, list item, and so on, producing different types of layout nodes. But since it's virtual, in our case, in input element, we are doing a custom version where we create either a GUI button thing for submit inputs, and for any other input, we just create a text box. So I think what we're going to do here is very, very simple. We're just going to say if type is hidden, return null pointer, and that'll be it. And I have a feeling that this will break things, so we'll just see what it breaks and then fix that. Because this type of stuff tends to be really fragile. Okay, so two issues. One, we didn't get the image showing up, and two, when I hovered the web page, it crashed. All right, so this part is okay, but if I hover, we die, and we crash in layout tree builder. We're trying to do a style update on the document, presumably because I'm hovering and then like the hovered element changes, and so we do a style update because we have to do a style update because we need to figure out if something that we're now hovering has a different style, and it's not very efficiently built, but that is what we do. And I bet you that in layout tree builder we have some assertion there. Okay, so why is that? Support building partial trees. So right now we only allow building a layout tree for the document node, and the reason is that when we create a layout tree, we can only do it for one element at a time. And if we do it from the top down, from like the document level all the way into all the little elements, that's fine because then we're controlling it. But if we want to do selective update on a single thing, which I guess is probably what's happening here. Yeah, so we're calling element recompute style. So we're trying to recompute the style for a specific element, and it's failing because we don't allow that. Well, recompute style. So we're probably here. So let's see. So recompute style on an element that doesn't have a layout node. So that'll be an element with display none. Or, well, an element with display none, or in our case, an input with type hidden. So normally we would just bail here because we would look up the display property, find that it is none, and then just return. Otherwise, it's like, okay, well, we do need to build a new layout tree. And then I think we just never exercised this code path because we didn't have... Basically, the situation here is that like you had a node, a DOM node that was previously display none or invisible for whatever reason, and now it wants to participate in layout, so we have to create a layout tree for it. So I think that'll be the inputs that are hidden. So we can probably just get around this temporary, extend the temporary grace period here by saying that, let's see. So the issue is that we don't want to create a partial layout tree because we don't know what to do with any subtree that we might generate. But if the node has no children, then it would be okay to make a new layout tree because now we know that it's only going to be that for that one node anyway. So it's a little bit cheesy, but it takes us out of the issue for now. Okay. All right, and now we can hover, but our image is gone. So let's just verify in the DOM inspector that it's still there. Probably in the center somewhere, probably here somewhere. Yeah, so this will be an image. And let's look at the layout tree to see, holy moly. Can we see how big it is? I think it's this one. It's 550 by 220 pixels. And it's at x129, y41. And it's not, you know, invisible or anything, so you would think that it would show up unless we are clipping it out or something. Let's see, layout image. So let's just log something here. Layout image render is visible. And maybe the, oh wait, it's gonna be this thing. Let's see. So if the ViewportRekt does not intersect with the rect of this image, then we don't render it. So probably it's either that it's not visible or that we don't intersect. The image doesn't intersect with the ViewportRekt for some reason, although it's clearly like in the viewport. So let's see, rect and ViewportRekt is context ViewportRekt. All right, and then we can work out what's going on. All right, so visible is true, and the rect is, this is our logo, right? Oh yeah, and this is some smaller image that I don't know what that is. I don't know, but anyway, the bigger image is, wait, this is the bigger image. But the viewport is suspiciously small. Because how big is this window anyway? It's like 640 by 480, and the ViewportRekt is 636 by 29. So I'd say that that's inaccurate. Like the ViewportRekt is clearly at least, I don't know, 300 something pixels, right? let's take a look at the layout tree, see what how big the body element thinks it is. The body element thinks that it is 30 pixels tall. So clearly we are not accumulating height correctly in this layout tree. And that could be for a billion reasons, but I think we should still render the layout image. So I think the ViewportRekt is just totally wrong. So who decides that? Who decides the ViewportRekt? Rendering context, set ViewportRekt. Oops, who calls it? It's HTML view. Call set ViewportRekt. And then we say that it's the visible content rect. So the visible content rect of the HTML view becomes the ViewportRekt. Well, alright, so I guess the visible... so this is inherited from scrollable widget. So HTML view, the HTML view widget inherits from GUI scrollable widget. And the scrollable widget has this concept of content size. So a subclass of scrollable widget tells the base class, hey, the content inside the scrollable widget is this large, right? And we use this for the text editor component and for like table views and stuff like that, but also for the HTML view. And basically what you do is you call what is it, set content size or something? Set content size. And it is a protected method. So we call this in a bunch of places, for example, in HTML view. And we say here, set content size to the enclosing int rect of the layout root. So the root of our layout tree determines the content size of the HTML view. And I think when it comes to, I mean, it's okay to consider that like the viewport, or to consider it the content size, because this is the content size, even though it's wrong, right? This is how big we think the web page is. But the ViewportRekt is clearly different, because the ViewportRekt, like even if the content is only like 100 pixels tall, the ViewportRekt should still be however large the viewport is. So I think maybe we will add a function here to HTML view, like update viewport, or no, not update, compute ViewportRekt maybe. And basically compute ViewportRekt. All right. And what this will do is it will take the content. Wait, what did we call it? The content rect? Content size? What? Wait, what am I thinking of? The visible content rect. The visible content rect. This is going to become the ViewportRekt. So the ViewportRekt is the visible content rect, but the size of it is going to be the size of the viewport. So we discard whatever we thought the size of the content was. We don't care, because the size of the ViewportRekt is the size of the viewport. Okay. And scrollable widget has something for this. So it would be not the visible content rect, but the widget inner rect. That is the ViewportRekt, which, I don't know, maybe that would be a good name for that function. Widget inner rect is a bit weird, but we think we can just call it here, widget inner rect size. All right. Oh wait, hold on, we're not doing anything with this yet. And then wherever we do content rect, visible content rect. So ViewportRekt is going to be compute ViewportRekt. This feels like it could just as well live in scrollable widget, actually. Like, why does it have to be in HTML view? So let's put it there. So ViewportRekt. It's the ViewportRekt in content coordinates, basically. So not the visible content rect, the ViewportRekt in content coordinates. Yes, that's what it is. Okay. And wherever we were doing, so now instead of compute ViewportRekt, we just say ViewportRekt in content coordinates. Visible content rect. Yeah, so this kind of just rewrites itself, right? Set ViewportRekt in content coordinates. Okay, so what are we doing here? Scroll to anchor. Here we are only concerned with the width and the height of the visible content rect. That's a little bit weird, but I guess we could switch that code to using the viewport. Well, it's only using the size. Okay, I'm not gonna mess with this one because I'm not in the right headspace for scroll to anchor. So, because there's all kinds of things to get right with that, but I feel like this should give us a good viewport here. Yeah. Okay. So now our viewport is from 0, 0 to 636, or 636 by 381. And that's the viewport in content coordinates. So basically like document relative offsets. And oh, look at that, there's our other image. It's pretty cool. So getting rid of those input type hidden is pretty nice. I wonder what all of these weird dark things are. I guess they're probably menu or something. Anyway, this is really nice. So let's see. Let's add this function here to scrollable widget. Let GUI add scrollable widget ViewportRekt in content coordinates. And don't produce a layout node for input type hidden. But don't generate a layout node for input type hidden. That's cool. And then in the layout tree builder, that's just that little change to not crash. So we allow ourselves to try to build a partial layout tree as long as that partial tree is a single element. So it's just working around or like postponing having to deal with partial layouts or partial box tree builds, essentially. Don't assert when trying to rebuild a single node layout tree. This merely postpones dealing with partial layout tree rebuilds for a while longer. Okay, and then in the image we were just logging, so I think we can probably just get rid of that. Okay, we are making pretty good pace today, and I don't have so much time, so that's perfect. And then compute ViewportRekt. I didn't even add that function, so let's get rid of that. And now all we have left is HTML view, so libweb. Use the full pass the plumb, the full ViewportRekt down into the engine. Previously, we would use the content.rect as the ViewportRekt, which could sometimes be smaller than the actual ViewportRekt, as the content size was completely, or it was based on the layout dimensions, the box geometry of the root layout node. This allows images. This fixes an issue on Google.com where we would not render the main logo image since it was outside the viewport. Viewport size is, or the layout, the root layout size is currently very wrong on Google.com, but that's a separate issue. Oof. All right, so that's a whole bunch of committing, but I think the results are pretty nice. So we got rid of these pesky input type hidden. Of course, we have other issues, like why is this input here so small? How am I supposed to Google with this tiny text box? I wonder why it's so small. Maybe we can just get a quick look at it. I wish that would, it would be nice if we had a way to like right click on an element to inspect it, but we're missing so many pieces for that. But maybe we can at least figure out where you are, little button. This is weird, by the way. Like, we have this box here, even though we think that the whole document is smaller than that. Like, clearly, we're making some mistakes in the layout logic. But if we're going to keep working on the Google website, we're going to need to do more layout stuff. So that might be good. It would be cool to get this page working fully. So I came here looking for the text box, which, is it this one? No, this one is hidden. Oh, is it maybe this one? What am I looking at? Right here. Oh, I bet it's you. Okay, so it's an input class, whatever. But does it have a size attribute? Look, I put, how am I supposed to Google with this? This tiny text box. Size 57. I would have expected that to be bigger, but maybe we don't care about the size attribute. Oops. HTML input, text box. I guess maybe we just don't care. We just look at the text width. Oh, I see. So we look at the value attribute at the time of creating the layout node. But we could actually teach it to look at the size attribute. I thought we were looking at the size attribute, so I was just wrong about that. Let's fix that. So what will be the policy here? I guess if has attribute size. Let's just write this in an expressive way and we can worry about other stuff later. So if we have a size attribute, first we'll say that like that can be the default, but then if size, then text width is graphics font, default font, glyph width of the X character, because why not? Times attribute size to int. Oh yeah, okay, let's write this in a little bit more careful way. Size attribute size 5. Size, okay, and then if size value is not null, then size is size value to uint, or maybe int is fine too. And then if okay and size greater than 0, then we will set that to be the text width. Otherwise we'll just use the fallback of the size of the value, wherever it was pre-populated with. So let's try it. See if we can get a wide enough thing to type into. Wouldn't that be nice? Poof, look at that. Finally, we have some space for a search. Okay, and can we search? We can't, because whatever, but we don't have to solve that today. At least this is some nice progress on the layout of the page. Got rid of some stuff that was not supposed to be there, fixed up the size of the search box. Very nice. So respect the input size attribute a bit more. Now use the size attribute to determine the width of a text input. Yeah. Okay, cool. I think this is going to be it for today's video. So it's a little bit shorter one, but it's some good progress. So if you made it this far, then I thank you for watching, for hanging out, and I hope you saw something interesting. I think this is pretty satisfying stuff to make a little progress, and maybe we'll do more of these as we make progress on Google. And I'm sure we'll have to make progress on other web pages too, but here we are right now. These are pretty fun problems to have, so not complaining. Anyways, thanks for hanging out. I'll see you next time.